denatured all the proteins, right? So it's no longer clear and would be much tougher than it is in real life. But still, I would say once you're done with the rest of the dissection, you might want to go ahead and cut through that cornea just to get appreciation for how thick it is. Right? It's just like skin. It's heavy-duty tissue, except that it's clear. Right? Cattle tend to pigment, put a lot of black pigment right around the edge here, so the cattle don't have that straight from pupil to the white of the eye, which we call the sclera. Right? It's a little bit different organization than what the human eye has, but you still get the same appreciation. This would be referred to as the scleral area around the outside. And again, there's no variation on pigmentation in the cattle eye. That's just their genetics. For us, you know, we all appreciate you can have everything from green to blue to black and all sorts of variation in between. Have a look at the back of the eye before you cut into it. There's that optic nerve, right, sticking up. Picked one that was pretty easy. And it's surrounded by, of course, all this reddish material you see in here are the extrinsic muscles of the eye, right, that move the globe around. Right? None of these muscles out here have anything to do with focusing, visual acuity, anything like that. It's just looking around, right, moving the globes. Of course, the tricky thing about all these, and this is why they have all those individual cranial nerves, is that this muscle right here needs to move in exactly the same pattern as its sister muscle does in the other eye. Right? If we're going to maintain good panoramic vision and good visual acuity as we move around, both globes have to move exactly identically, right? Now that's not these are skeletal muscles though, right? We have conscious control over these. And some people are better at it than others, but you can consciously cross your eyes, right? And I've even seen a couple of people, it's much rarer, they have that abducens ability to control the abducens muscle, and they'll actually make their pupils rotate out a little bit. That's much rarer to see, but I have seen it before. But most of us can at least cross our eyes. But we appreciate if you do that, you're losing visual acuity, right? Because the light rays aren't aligning anymore. Okay, so there's optic nerve, some of the extrinsic muscles, all this yellow stuff. What is that?
Adipose.
Adipose tissue, right? Mostly protective in this case. The eye is not a big consumer of energy at all. The brain certainly is, but the eye is not. This is about protection, right? All animals do this. We certainly do this. We put a lot of adipose tissue, pack it around those muscles so that if we take a concussive blow, the eye can move around in that socket without hitting bone, right? Adipose tissue is much more flexible so that we don't explode the eye. First of all, it's a fluid-filled balloon, so it has the potential to rupture, right, if you had too much of a trauma in there. And then the other thing, again, is that retina is not directly attached to the surface of the cornea, right? If you take a big enough blow to the head, you can dislodge that cornea, and it will literally fall off the surface of the choroid, right? Good news is if you haven't, in any other form or fashion, damaged the retina, if you can get the retina to lay back onto the surface of the choroid correctly, you'll get your vision back, right? This is where if you've seen movies or documentaries on this is where they put the person in that, what looks like a torture chamber, right? They're all stretched out and they're strapped down, and it's like a gyroscope. They'll move it so that their head is toward the floor, feet toward the sky, and then they'll rotate and move them around, and they're trying to get gravity to make that retina fall back onto the choroid, right? So they don't have to go in and do surgery and try to manually replace it.
Wouldn't it just fall back once they got into the other position?
Well, your hope is that you've got enough vitreous humor in there that once it falls back into the position on the retina, that the vitreous will help hold it in place. But as you probably are right in thinking, it doesn't always work out that well. Sometimes it does, sometimes it doesn't. If it's a small detachment where just a little piece of the retina is sort of hanging down into the vitreous, you have an excellent chance of it going back. If you have had the retina collapse all the way down where it's like folded on itself, no, you're probably going to have surgery to have it fixed. I'll try to pull out eyes that don't have a huge glob of muscles around here so you don't have to trim. If you get a specimen like this, you really don't need to trim any of these muscles or do anything else to it. Just go ahead and bisect the eye. What you want to do here is you want to stay at the greatest diameter of the eye. And that tends to be about half an inch or so behind the level of the cornea. And then just stay parallel to that all the way around. So and again, the choroid now is pretty tough stuff. So you may have to saw on it a little bit. Be a little careful here. Now remember, formaldehyde has filled up that inner portion here. So if you're sort of squeezing and really cranking on this thing, as soon as you break in here, you may get a little jet. So sort of do this at arm's length so you don't get a bunch of formaldehyde on you. And you don't want to go real deep here. just get through the surface of the cornea. There we go. Now I've got the corner of the blade in there. It's as deep as you need to go once you're through the choroid. And then just slowly work yourself all the way around, staying about the same distance from the level of the cornea. All right, and I'm going to leave this attached here for now. And that's about right. That's about what you want. Okay? Now, as I cut through here, I clipped part of the retina, so it's already collapsed down. So I'm going to try to reattach it here. There we go. All right, so the brownish tissue that's sitting on the back of the eye. So I have cut into the posterior chamber. Everybody see that? And that brownish material you see on the back of the eye is the retina itself. That gelatinous material you see in there is the vitreous. All right, and if I scoop all of that vitreous humor out, with it will come the lens. Right? You get that sort of an egg appearance there. Okay, so that's the lens, which again would be clear in life. Formaldehyde has changed its color. And the black that you see there are part of those ciliary body tendons that were attached to the edge of that lens. Right? And then as you look then to the back of the iris, essentially, what you're seeing here are, if you look at this closely, it reminds me of the bottom side of a mushroom cap. You get those lines that are going through there. Those are the tendons, part of the ciliary body, that are directly attached to the lens. And then as you get very close here to the center, cow hair? That could be from the tail. I bet that's what it's from. Probably off the tail or the mane. I suppose it could be human hair, but I'm thinking, why would that be in there? You never know. You can see the pupil in the center, so that's the hole in the center, and the tissue that is right next or rims the pupil right there is shiny and smooth. It does not have those regular radiations in there. That's the iris, which again in cattle is always going to be black. So there's your ciliary body iris. And then cornea on the surface, and between the cornea and ciliary body would be anterior chamber. So the anterior chamber is much, much smaller, right? It's a very thin space just in front of the lens and behind the cornea. Posterior chamber is much larger. Right? And then if I take the retina and just manually collapse it all the way down, so you see it was spread out all over the back of the eye. Now I've taken it down to where it's just attached in one spot right there. That's the optic disc. Right? That's where the retina dives down in and becomes the optic nerve. And now you all see that blue mother of pearl look in there? That's the tapetum that you would not see on a human eye dissection. Okay? Pretty straightforward dissection, right? Not a whole lot of things to identify here. I'll get some eyes out for you. You guys can dig in.
It is squishy.